welcome back. In this video, I'm going to be proving the product rule for you again, but this time I'm going to use a different technique. Okay, I'm going to use implicit differentiation, I'm going to use really it's logarithmic differentiation. And this is going to be a much nice, smooth way to show that the product rule works, but you need to be through about Unit 4 of my CalBC class to understand this. So if you're not there yet, just come back in a couple weeks or a month or something, and you will get it. All right, so what I'm going to do is I'm going to say let y equal f times g, okay? Where by y and f and g, I mean functions of x, okay? I'm just going to assume you understand what I'm saying there when I say y equals f times g. So what I'm going to do is I'm going to take the natural log of both sides of this equation. And now I'm going to apply a log property. Remember, the log of the product is the sum of the logs. And so that's going to be equal to the log of f plus the log of g. And now I'm going to take the derivative of both sides of this equation with respect to x. Okay? And maybe I'll even write that in. Okay, so I'm going to take the derivative with respect to x of log y, and that's going to be equal to the derivative with respect to x of log of f plus log of g. Okay. Derivative of natural log of y with respect to x is going to be 1 over y dy dx. And I'm hoping to find dy dx and show that it's equal to that, right? Probably forgot to mention that at the beginning. 1 over y dy dx is equal to the derivative of this. Okay, well, this is going to be 1 over f times the derivative of f with respect to x, which would be, okay, so it's like 1 over f times f prime plus 1 over g times g prime. And I guess I could have called this y prime. That's just not usually a notation I use in my AP calculus class. So when I go and multiply both sides by y to solve for dy dx, I'm going to combine these into a single fraction, f prime divided by f and g prime divided by g, so that I can say that, all right, dy dx is equal to y times f prime over f plus g prime over g. But we already know what y is equal to. Y is equal to f times g. Okay? So this is equal to f times g, really f of x times g of x, times f prime of x divided by f of x plus g prime of x divided by g of x. And then when I go and I actually make that distribution here, well, the f's will cancel and I'll have gf prime. And then when I distribute over here, the g's will cancel and I'll have fg prime. Which is not exactly how I wrote it. Oh, no, it's just like the opposite of how I wrote it up here. Okay. And so this is a much nicer, easier way. I think it maybe kind of gives you a better idea of like, where is this really coming from? Than just, doing algebra tricks on the definition of the derivative. So here it is. This is the proof of the product rule with logarithmic differentiation.